Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your sources of edible oil and fats and their processing and refining. Okay. So in the previous lecture we are already discussed about the introduction of the introduction of the edible oil and fats. Okay, we also discuss about the fatty acids, glycerides, and even we are discuss about the physical and chemical properties of the triglycerides. Okay, so this portion we will we was also we already covered. Okay, all these portion we are already covered. Now, in today's lecture, what should we are going to do? We are going to see that what is the sources of this edible oil and fats. Just a minute. What is this? What is the sources of this edible oil and fats, and how we process this edible oil and how we refine this edible oil and fat. All these things will be discussed in today's lecture. Okay, so let's start today's lecture. The first topic is your sources of edible oil and main fats. We all know that from we get a fat and this fat and oil from a hundred of plants and animals. Okay, and they can produce a sufficient quantities of this edible oil, and there are only few sources which are commercially significant. Okay, so again we discuss the table which summarize that the major sources of the different method of the processing of this edible oil and fat in the different um, in the different areas of the world. Okay, so in table 4.8 all these things are summarized. Several hundred plants and animals produce fats and oils in sufficient quantities to warrant processing into a edible oil. However, only a few sources are commercially significant. Okay, there are several methods of producing of this oil and fat, but among them only a few sources are commercially significant. Okay, and in the next slide there is a table which summarize the major sources in the world and the methods of processing. The organ fat of domestic animal like your cattle and hogs and milk fat are also important for the raw material for the production of the fat. Okay, so milk fat are very important because this milk fat are used as a raw material for the production of different fat. Okay, we all know that this edible oil what they are mostly produced from a plant. That's why it is called a plant origin. Like your olive oil, palm oil, they are extracted from the fruits. Okay, olive oil and palm oil, these are the two types of the oil, that is your palm oil and olive oil. They are extracted from the fruits, and there are other types of oils which are extracted from our oil seeds. Now the world production of oil seed and other crops also have a significantly increase in a recent years so that they will meet the growing needs for oil and fats in the world. Now the next is your the table which shows that the major sources of the edible fats and oil in our world and their methods of processing. Okay, now the first table is for the sources, then the amount of oil present into it, and then the methods of recovering. Okay, so the first oil is your sorry, the first source is your soya bean. Okay, so in soya bean, it contain around 90% oil and it can be recovered from a direct solvent extraction. Okay, now the next is your corn, which contain around 40% of the oil and it can be recovered by the method that is called a wet or dry milling and pre-press solvent extraction. The next source is your tallow, that is your edible tissue. Okay, it contain around 70 to 95% of the oil and it can be recovered by the method that is called a wet or dry rendering. Okay, now the next source is your canola, which contain around 42% of the fat and it can be recovered by the method that is called a pre-press solvent extraction method. Next source is your coconut, that is your dried copra. It contain around 66% of the oil and it can be recovered by the method that is called a hard pressing. Next is your cotton seed, which contain around 19% oil and it can be recovered by the method that is called a hard pressing or a pre-pressing or direct solvent extraction method. The next source is your lard, that is your edible tissue. It contains around 70 to 95% of oil and it can be recovered by the method that is called your wet or dry rendering. Okay, next source is your palm, which contain around 47% of the fat, sorry, 47% of the oil and it can be recovered by the method that is called a hard pressing method. Next is your palm kernel, which contain around 48% of oil content and it can be recovered by the method that is called your hard pressing. Next source is your sunflower, which contain around 40% of the oil and it can be prepared by a method that is called a pre-press solvent extraction method. Last source is your peanut shell and it contain around 47% of the oil and it can be recovered by the method that is called your hard pressing or pre-press solvent extraction. So these are the major sources and their methods of processing and even the oil content present into that sources. It can it describe in a summary. Okay, now the next is your world oil seed production. Okay, if we take a data from 2003, then world oil seed production is around 335.9 million tons. Okay, so there is also a figure in the next slide which is called a figure 4.2, which shows that world production of different oil seeds. Okay, now soybean cons constitute the largest share, that is 56%, and United States in a main crop grower. Malaysia grow a mainly palm. Okay, so in Malaysia the mainly oil sources what they are palm. The Philippines grow coconut, so coconut is the main source of oil in Philippines, and in China, Europe, India, and Canada they grow a rapeseed for the oil production. Sunflower is grown in the United States, Australia, Europe, Argentina, and the cotton seed market is dominated by the United States, China, Pakistan, India, and the former Soviet Union. Okay, now the next is your world vegetable oil consumption. Okay, so the previous one is the oil consumption. Now this is the vegetable oil consumption. So world vegetable oil consumption in 2003, again we take a data from 2003, then it is around 87.2 million ton. US consumption was about 9.91 million tons, and in US market, animal fat, that is called a tallow or a lard, have a relatively small share, that is only around 2% as compared to a vegetable oil. Okay, so the consumption of four oil, that is your soya bean oil, it contain around 80%, and corn it contain around 4%, canola it contain around 4%, and cottonseed it contain around 3%, has grown rapidly over the past 30 year, which is compared to the traditional oil and animal fat. Okay, so again there is a figure that is called 4.3, which represent in the next slide, which shows that the US consumption of the edible fats and oil in 2003. Okay, now the next is your, this is the world oilseed production data from 2003. Here you see that the major portion are covered by a soybean, that is around 56%. Okay, the major portion. Then after that, rapeseed, that is 12%. Then cottonseed, that is 10%. Then peanut, that is also 10%. Sunflower seed, it contain around 8%. Palm kernel 2%. Copra 2%. Okay, so if we take a view that how much million short ton are produced these soybean and rapeseed, then it will soybean produce around 209.5 million short ton and 190.1 million metric tons. Rapeseed produce 43 million short ton. Cottonseed produce 38.7 million short tons. Peanut produce 35.4 million tons. Sunflower seed produce around 28.7 million tons. Palm kernel produce around 8.9 million tons. Okay, and copra produce around 5.9 million tons, and it is total around 370.1 million tons. Okay, so this is the total, and the source is from USDA. Now the next is your oil and fat processing and refining. Okay, so after the sources of the edible and edible oil and fat, the another topic is that which we have to cover is a oil and fat, that they are processing and they are refining. Okay, we know that this crude fat and oil consist of primary glyceride. Okay, so crude fat and oils are made up of glycerides, we all know that. Okay, however they also contain many other lipids, but in very minor quantities. Okay, other than this glycerides, many other many other lipids are also present, but they are present in a minor quantity. For example, like your corn oil, for example, it contain a glyceride plus phospholipids. Okay, but the quantity of the phospholipid is very small. It also contain a glycolipids, many isomers of the um, cystosterol and stegmasterol, that is your plant steroid, several tocopherol, that is your vitamin E, vitamin A, waxes, unsaturated hydrocarbons such as squalane, and dozens of carotenoids and chlorophyll compound, and as well as many other product of decomposition like your hydrolysis, oxidation, polymerization, or any of the natural constitutes. Okay, now the next is your all crude fats and oil which are obtained after a rendering, crushing, or a solvent extraction. Invariably it contain a variable amount of non-glyceridic constitute. Okay, so all the crude oils or a fat which are obtained either after rendering, crushing, or a solvent extraction, it contain a variable amount of non-glyceridic constitutes, and this non-glyceridic constitute like your fatty acids, partial glycerides, that is called a mono and diglyceride, phosphatidides, sterols, tocopherol, hydrocarbon, pigment, that is glycol and chlorophyll, vitamins, carotene, steroid, glucosides, protein fragment, and as well as resins and mucilaginous material, which are material stresses of the pesticides and heavy metals. Again, there is a table 4.9 which shows that the important of the constituents which are found in some major oil, and some of these materials are highly undesirable. Okay, so these material are high undesirable, and for and it must be removed so that it will provide a satisfactory processing characteristic, and also provide a desirable color, odor, flavor, and also keep the quality, and also prevent the finished product quality. And you can, or you can also set that also maintain the, also maintain the quality of the finished product, quality of the finished products. Okay, now the next is your US fat and oil edible consumption according to 2003. Again, you see that soybean contain a 80%, canola contain a 4%, cottonseed contain a 2%, lard 1%, edible tallow 1%, coconut 1%, peanut 1%, and other it contain 10%. Now see that how much million pounds of soybeans are produced, and how much million metric tons these all things are produced. And the sources are taken from, again taken from a USDA. Okay, so soybean is produced around 17.471 million pounds. Canola, that is your rapeseed, it produce around 857 million pounds. Cotton seed are produced around 482 million pounds. Lard are produced around 205 million pounds. Edible tallow are produced around 236 pounds. Coconuts are produced around 310 million pounds, and peanut is produced around 185 million pounds. Other are produced around 2112 million pounds, and the total is around 21,858 million pounds. Now the next is your minor component in some major oil. Okay, so here the first table is for the component, then soybean or percentage in soybean oil, then percentage in canola, and percentage in palm oil. If we take a free fatty acid first component, then it will be, it will then it produce it present in soybean oil around 0.3 to 0.8%, in canola 0.3 to 1.0%, and palm oil is around 2.0 to 5.0%. Phosphatides, in soybean it is present around 1 to 3%. Okay, just a minute, 1 to 3%, and in canola it is present around 0.5 to 3.5%. In palm it is present around 0.03%, 0.03 to 0.1%. The next is your ester oil or triterpenic alcohol. In soybean it is present around 0.04 to 0.07%. In canola it is present around 0.04 to 0.6%. In palm oil it is present around 0.1 to 0.2%. Tocopherol or tocoteranols. Okay, so in soybean it is present around 0.06 to 0.2%. In canola it is present around 0.06 to 0.1%. In palm oil it is present around 0.05 to 0.1%. The next is your carotenoid. In carotenoid present in soybean oil around 40 to 50 ppm. In canola 25 to 70 ppm. Palm oil 500 to 800 ppm. Next is your chlorophyll and pheophytine. In soybean it is present around 1 to 2 ppm. In canola it is present around 5 to 30 ppm. In palm oil the traces are present. The next is your peroxide, less than 10 in soybean oil, less than 10 in soybean oil, 1 to 5 in palm oil. Sorry, more than 10 in soybean oil, more than 10 in canola oil, and 1 to 5 in palm oil. Then iron and copper. Iron are present in soybean oil around 1 to 3 ppm, 1 to 5 ppm in canola, and 4 to 10 ppm in palm oil. Then copper are present 0 to 3 pp in soybean oil, 0 to 30 ppb in canola, and 0 to 50 ppb in palm oil. So this is the minor components which are present in some major oil. Now the next slide. These objectable constitute are removed during the refining process. Okay, so when there is a refining are performed after processing, after processing The another step is refining. So in the refining process, all the objectable constitutes are removed during this refining process in such a way that glyceride, yield, and the desirable constitute in the oil are not affected. Okay, so when we are removing the unobjectable constitute during the refining process, we have to take care one thing, that the glyceride, yield, and the desirable constitute will not affected. Okay, so figure 4.4 shows that the different stages is in a seed preparation and a classical chemical refining process. Okay, so this figure 4.4 will be present in a next slide, which shows about the different stages of the seed preparation and also describe the classical chemical refining process. So the general method which is used to produce a edible oil for a human consumption, it consists. Okay, so the first step is a seed preparation, then extraction, then degumming, then neutralization, bleaching, deodorization, hydrogenation, and sometimes winterization. Okay, so these all the step we are going to discuss in today's lecture. That the first one is your seed preparation, then after that we discuss about the degumming, then neutralization, then bleaching, then deodorization, and then hydrogen and sometime winterization. So there are 8 steps that we are going to discuss in today's lecture. So come to the next slide. So this is the figure which shows that the is essential step in the extracting and refining of the edible oil from a oil seed. First of all, what we have to do, we clean the dry oil seed. Then after that, dehulling or a dishulling. Then crush to a pulp. Okay, when dehulling is performed, then hull or shells are removed. Then crushed to a pulp. After that, screw press, here oil virgin and water refining. Then pulp dry to a flag. Then we perform a solvent extractor, solvent remover, or a solid product. If we get a solid product, then we dry it and we use it as a meal. Then solvent remover, then alkali refining, bleaching, filter, deodorization, refined oil, and this refined oil are what, waterization and hydrogenation if it is required. Okay, so in solvent extractor we use a solvent, that is your solvent hexane. So these are the essential step which we required when refining of edible oil from oil seeds are performed. Now, the first one is your seed preparation. When oil seeds are received at an oil mill, they still contain plant residue. Suppose that this is your oil seed. Okay, so this oil seeds are received in a oil mill. This is your oil mill. Now, it contain a residue of the plant, and along with it damaged seeds are also present, dust present, sand, wood, pieces of the metal, and foreign seeds. Then the oil seeds are carefully cleaned of these material using a magnet, screens, and aspirator system. Okay, so for removing all these material which are not useful for the oil preparation, we remove it with the help of either using magnet, screens, and aspirator system. Then the clean seeds are dry so that it will remove the moisture. Okay, after removing all these things, that is your plant residue, damaged seed, dust, sand, wood, pieces of the metal, and the forest seed, um, these clean seeds are dry so that it will remove the moisture. Now next, the dry oil seeds are usually decorticated so that it will remove the hull that surround the oil seeds. Okay, we all know that this is if this is a oil seed, then a hull cover this oil seed. So we have to remove it before being further processed. Hull always contain a much less oil than a kernel or a metals. Okay, so this the amount of oil is also less in hull. further remove the hull, it also reduces the amount of material that must be handled. When the hull is removed, then the weightage of the seed will also decreases, and it will also decreases the amount of material that we handle. Then extracted and refined. Dehulling is normally pre-formed very carefully so that it will ensure that the meat is not broken into a many small pieces. Now, corrugated roller mills or a bar mills are used so that it will cut or break the hull. For the cutting or the breaking of the hull from a free meat, we uses a corrugated roller mills or a bar mills. The hulls are separated by screening and air clarification. Hulls may be blended back with a meat so that it will control a protein level, sold as a cattle feed or a burn in boiler so that it will generate a steam and a electrical energy. Now the next is your extraction. The raw material for the fat and oil industry come from our animals. Then animals may be hogs, sheep, and fatty fish. Fleshy fruit, that is your palm or olive, and various oil seeds. Most of the oil seeds are grown especially for the processing of the oil and protein meals. Now the next is the purpose of the oil extraction is what? The, there is a two purpose of oil extraction. So there are two purposes of the oil extraction. The first is that extracting the maximum amount of good quality oil. Okay. The first purpose is what? We have to extract the maximum amount of good quality oil. And the second purpose is that getting a maximum value from the residual press cake or a meal. Okay, so there are three methods which we are used for the extraction with varying degree of mechanical simplicity, and they are what? They are rendering, pressing with a mechanical process, and extracting with a volatile solvent. Either we do a rendering so that we get a maximum amount of good quality oil, either we press it with a mechanical press, or either we extract it with the use of the volatile solvent. Now the next is your rendering. Okay, so rendering is the process of extraction. Rendering is the process of extraction. The rendering process is applied on a large scale to the production of animal fat. Okay, so when we have to produce a large amount of animal fat, we use a rendering method. Okay, for the production of the tallow, lard, bone fat, and well oil. Okay, so for the production of tallow, lard, bone fat, and well oil, we use our rendering process. The fatty tissue are chopped into a small pieces and then boiled into a steam digester. Okay, so fatty tissue are chopped and converted into a small pieces, and then it boiled into a steam digester. The fat is gradually liberated from the cell and floats to the surface of the water, where it is collected by a skimming. A similar method which is used in the extraction of the palm oil from a fresh palm fruit. Now the next is your pressing. Again, this pressing is the method of the extraction. Oil seed do not have a fat cell like those of animal for storing a fat. Okay, so we all know that animal can store a fat, but in oil seed there is no fat cells are present which can store the fat. Instead of oil, it is stored in a microscopic globule throughout the cell. In these cases, rendering will not liberate the oil from the cellular structure, and the cell wall are broken only by a grinding, flaking, rolling, or pressing. And this pressing will be done under a high pressure so that it will liberate the oil. The general sequence of modern operation in pressing oil seeds and nut is as follow. The first one is your preparation of the seed so that it will remove the stray bits of the metals and also remove the hulls. Reduction of the particle size of the kernel by a grinding method. And the third step is what? Cooking and pressing in a hydraulic or a screw presses. Efficient oil extraction by a mechanical press are highly dependent on having a correct preparation before a pressing. Okay, if the preparation of the pressing is not exact that we get from a mechanical press, then the amount of extraction will also decreases. The extraction stage itself is carried out by using a screw press, which you shown in a figure 4.5. The then the press is fed by means of variable speed conveyor within the feeder unit. The feeder the feeder regulate the flow of material into the press, and thereby it control the loading on the press main motor. Or then oil are released along the length of the cage, which allow to drain into the base of the press where it is collected. The solid material that is called a press cake remaining within the press is finally discharged into a conveyor so that it will remove for subsequent processing or a storage. Now the next is your, see, this is a screw press method. Here you add the feed. This is your cage. Okay. Now here a screw are there. It press the cage and oil are extracted. See, oil are extracted. And from a feed, only a press cake are removed from this side. Here the oil are collected and here the press cake are collected. Oil expressed without heating, it contain the least amount of impurities. Okay, so when oil are extracted without the heating, then it will contain a least amount of impurities and is often of edible quality without refining or further processing. Such type of oils are known as a cold drawn or a cold press or a virgin oil. Cold drawn, cold press, or a virgin oil in which the heat is not used. The express oil from a cooked seed contain a greater quantities of non-glyceride impurities like your phospholipid, color bodies, and saponifiable matter. Now, such oil are highly colored and are not suitable for a edible use. Okay, if it contain impurities like phospholipid and color bodies, then and unsaponifical matter, then this type of oil are what? They are highly colored and it is not suitable for a edible use. Now the next is your solvent extraction method. The press cake emerging from a screw press still retain 3 to 15% of residual oil. So this oil can be extracted with the help of the solvent extraction method. Here the name suggested that what we do, we use a solvent, and this solvent have a greater tendency to bind with this oil and remove the oil from the feed, and then after that we evaporate this solvent and we only get a oil. More complete extraction is done by a solvent extraction of the residue obtained from a mechanical pressing. Okay, so after the residue which we get from a mechanical pressing, we do a solvent extraction method so that the complete extraction should be done. Greater the efficiency obtained in a solvent extraction process, it will encourage the industry for a direct application to a oil seeds. In the United States and Europe, continuous extracted units are used in which fresh seed flags are added continuously and are subjected to a counter flow of solvent by which intimate contact is achieved between the seeds and the solvent. So the common type of the solvent which is used in case of edible oil is what? It is a commercial hexane or a heptane, and commonly known as a petroleum ethane, whose boiling range is in between 146 to 156 Fahrenheit or 63.3 to 68.9 degrees Celsius. Okay, so after the extraction are done, then the maximum solvent recovery is also important at the point of the economical operation. So the solvent is recovered by a distillation method and it can again reused. That I already told you in the starting, that what should we do? We evaporate the solvent, or we distill this solvent so that it will recover and we will get the reused solvent and along with oil. The extraction oil is mixed with a pre-pressed oil for refining. The extracted meal also contain less than 1% of this residual oil. In large scale operation, solvent extraction is more economical means of recovering oil than a mechanical pressing. Now, the next is your refining, degumming, and neutralization. So, the usual refining of the vegetable oil involve degumming and alkali refining. Okay, so if we have to refine the vegetable oil, then this vegetable oil can be refined by a degumming or a alkali refining. Degumming mainly reduces the phosphatize and the metal content of the crude oil by mixing it with an acid and water. Phosphatides are also present in a free hydratable form, that is HP, or in a non-hydratable form, that is your NHP, and also present in the combination of some metal ion, that is your calcium ion, magnesium ion, or iron ion. In alkali refining, the non-hydratable form of this phosphatides remain behind in the oil after a acid treatment, and the free fatty acid formed during the hydrolysis, that is your lipolysis of the HP, and then further removed by a neutralization. Now the next is your degumming, also consists of treating the oil with the small amount, that is around 0 to 0.5% of concentrated phosphoric acid and water, which are followed by a centrifugal separation of a coagulated material, that is your lecithin. Then the process which we apply to many oil, that is in case of soybean oil, which contain a phospholipid in significant amount, then refining with the help of alkali, free fatty acids are removed that are formed during a lipolysis of the fat or oil before rendering or a extraction. Then this oil is treated again with the excess amount of caustic soda, that and the amount of caustic soda is around 0 to 1%, and then the mixture are heated at 75 degrees Celsius so that the emulsion can be, so that it can break the emulsion if it is formed. The mixture is allowed to settle, then the settling called a foods. When we allow that mixture so that it will be settled, then it is called a food, and they are collected and sold as a soap stock In a continuous system, the emulsion is separated with a centrifuge. After the oil has been refined, it is usually washed with water so that it will remove the traces of the alkali and a soap stock. After water washing, the oil may be dry by heating in a vacuum or by a filtering through a dry filter and a material. Now the next is your a whole variety of process have been developed so that whole variety of process have been developed so that it will improve the removal of the non-hydratable phosphatides. So the best known are the uni and super degumming process is Unilever, and the top degumming process, that is your one day mortal. They are principally based on a special type of acid treatment of the NHP over the last few years. Several new technologies are also approaches have been developed which give a guarantee that very low level of phosphorus are there, less than around 10 ppm. Okay, now the next is your in enzymatic degumming process. There is a part of hydratable phosphatides is enzymatically modified so that it will remove the fatty acid on the carbon number 2 position of the glycerol by using a phospholipase A2 enzyme as a biocatalyst. Now these modified phosphatide facilitate the removal of remaining NHP. Table 4.10 also show the different result of enzymatic degumming of a crude rapeseeds, and the phosphorus level are also reduced from 240 ppm to 4 to 8 ppm. Now the next is your example of enzymatic degumming. This is your rapeseed crude oil degumming. Okay, so rapeseed oil, it contain a phospholipid. In crude oil, it contain around 0.60%, and in degum oil, it contain 0.1 to 0.02%. Okay, phosphorus in crude oil, the amount of phosphorus is around 240 ppm, and in degum oil, it is around 4 to 8 ppm. Here it is clear that the amount of phosphorus are reduces from 240 ppm to 4 to 8 ppm. Amount of water in crude oil, it is present around 0.10%, and in degummed oil, it is present around 0.30%. Okay, here you can note that P content is a phosphatide content multiplied by 10, T divided by 25. Now the next is your, this is a reaction. Here it is, this is your phosphatide. This phosphatide react with the water in the presence of phospholipase A2 and buffer calcium hydroxide or sodium hydroxide, and their pH is around 5. Reaction time take around minimum 3 hours. Then it produces a lysolecithin. This is your lysolecithin. Okay. Now the next is your, if the soft degumming process is occurred, then the chelating agent, that is your EDTA, is added so that the oil can be removed. Oil remove the cation from a non-hydratable phosphatides, thereby making them hydrated well again. Okay, so here this is your phosphatides, this is your EDTA catalyst, then phosphatide EDTA, this is your metal ion, that is your calcium ion, magnesium ion, and ferrous ion. Now the next is your, in the improve acid degumming, special type of additives are used, and it will mixed into it so that it will improve the wetting of the NHP and hence their solubility in a aqueous phase. Furthermore, an intimate contain between the reaction product, that is your acid or alkaline, and the phosphatide also ensure that it will improve the hydrability of the NHP, and also if also efficiency of their removal. However, in all degumming process, the efficiency of the degumming treatment totally depend upon a great extent on the quality of the crude oil. A good quality of fresh oil is easier to degum than an adulterant oil. Okay, so if we have a fresh oil or good quality oil, then degumming process are very easier as compared to the degumming process of the adulterant oil. The direct consequence of the NHP to a HP ratio, the lower the NHP content, the easier the degumming process. If the NHP content is lower, then obviously the degumming process is good or better. Figure 4.6 also summarizes the different step of the degumming process in the form of process diagram. Okay, so here this is an example of the soft degumming, that is your soybean oil, crude oil, degum oil. Okay, soybean oil, phospholipids in crude oil, it is present around 0.30%. In degum oil, it is present around 0.01%. Phosphorus 120 ppm. In degum oil, it is present around 3 to 5 ppm. Calcium ion present in crude oil around 59, and in degum oil, it is present around 0.1%. Magnesium ion, it is present around 35% in crude oil, and in degum oil, it is present around 0.02%. Iron iron in crude oil, it is present around 1.6%, and in degum oil it is present around 0.04%. Now the next is your generalization flow sheet for degumming process, and the source are and the sources from that diagram are courtesy of Desmet Group, Antwerp, Belgium. Here it is your crude oil, water are added, mixing, then separation. Okay, so during the separation, hydratable phospholipids, drying, lecithin. Okay, again water degumming, mixing, then we added an acid like citric acid or phosphoric acid. NHP are converted into a HP, again mixing, and during mixing we add a NOH at pH 5. Here, free fatty acid are removed in the form of soap. Then separation, during the separation we get a non-hydratable phospholipid, that is your NHP, and then acid degumming, oil, then bleaching, then deodorization. So this is the step. Now the next is your bleaching. The refined oil are usually dark in color owing the presence of some pigmented material. Okay, so when we have a refined oil, then this refined oil are what they are usually dark in color. Why it is dark? Because of presence of some pigmented material like your chlorophyll, carotenoids, and minor impurities like residual phosphatides, soaps, metals, oxidation products. Bleaching also reduces the color by absorbing these colorants on the bleaching earth, or also activated the charcoal or both. So in addition to decolorization, bleach clay also absorb the suspended matter and minor impurities. Okay, so this bleaching process involves three stages or three steps. The first step is your initial mixing of oil with a bleaching earth. Next is your oil heating under a vacuum with a sparge steam, so that it will ensure a complete contact between the oil and the earth. The third one is your filtration or hermetic leaf filter, which are followed by a polishing filtration. The spent cake is direct by a steam blowing, and it is recovered by a oil is recycled. Then the bleaching is far the most expensive process in refining in terms of utility cost. The relatively high cost of the bleaching clay as well as the oil in earth loses the bleaching adsorbent disposable cost largely affect the operating cost of the bleaching plant. Moreover, the ever stronger environmental regulation are now forcing the oil refiner to drastically reduce mainly the solid waste, as these are the difficult to treat. Now several bleaching processes have been developed over the years so that it will limit the consumption of a bleaching earth. Figure 4.7 shows that the flow sheet of a double batch bleaching process. Double batch bleaching process. This is by far the oldest bleaching method still in use in many refining plant. This double batch bleaching process is what? It is the oldest method, but they can widely used in many refining plants. This is your flow sheet of double batch bleaching process with a acid pre-treatment. This diagram shows that. In order to reduce the bleaching earth consumption, alternative new multi-step process have been developed. After double bleaching method, uh, the second method, that is your multi-step bleaching method, are introduced so that the it will reduces the bleaching earth consumption. Next figure, that is your 4.8, shows that the flow sheet of a two-stage counter current bleaching with a pre-filtration process. The main function of a pre-filtration is that to remove all the solid impurities as well as also absorb most of the phosphatides and the soap. This increases the bleaching efficiency in a second stage. So this diagram shows that the two stage of a counter bleaching with a pre-filtration. Okay, here the vacuum, here it is a pre-filtration, then a bleaching doses, then a final bleaching, then final filtration, then a bleach safety filter. The next step is your deodorization. Most of the fat and oil, even after refining, have a characteristic flavor and odor owing to presence of minor amount of free fatty acid, aldehyde, ketones, and other compounds. So the concentration of this undesirable substances which are found in most of the oil are low, and the percentage is around 0 to 0.5%. So the removing of this undesirable substances are depend upon the vapor pressure of a different minor compound, deodorization condition, that is your temperature, pressure, residence time, amount of stripping steam, and the geometry of vessels. Deodorization are usually conducted at the range of temperature between 220 to 2600 degrees Celsius and the pressure between 2 and 4 mbr under the injection of 0.5 to 3% steam in a stainless steel. The different stages in a deodorization process, that is your deaeration, heating, deodorization, or a steam stripping, heat recovering or cooling, and final cooling. Hydrogenation. Hydrogenation is used to convert the liquid fat into a plastic fat, thereby making them a suitable for the manufacturing of margarine or a shortening. Okay, so this hydrogenation process are important for the manufacturing of the margarine or a shortening. Hydrogenated oil and a fat also exhibit improve the oxidative stability and the color. Close control of the hydrogenation result in highly specific result. For example, salad and cooking oil can be improved by control hydrogenation. Now the next is your winterization. Winterization is another operation that consists of removing from a certain oil the component that solidify at a low temperature, therefore are sources of the turbidity or settling in a bottle. The process consists in a filtering cooled oil under a strict control. Winterizing is not practiced so widely in a hot countries, and its application is restricted mainly in case of sunflower, maize, cotton, olive, rice bran, and partially hydrogenated soybean oil. The feedstock of the winterizing plant is usually bleach oil, sometimes neutralized or deodorized oil. Winterizing process completed in four steps. The first is your Oil is pre-cooled in a heat exchanger. The filter head is added just before the first crystallizer and the oil is cooled slowly in a minimum of 6 hours, a prerequisite for a gentle crystallization. The crystallized form stays 6 hours in a maturator at final cooling temperature. And the last one is that the oil is then filtered in a horizontal hermetic leaf filter. Okay, so oil temperature is often raised just before the filtration so that it will reduce the viscosity and facilitate the filtration. Normally, winterized oil remain clear at least 24 hours at 0 degrees Celsius. This corresponding to a wax content of a below 50 ppm. So this is all about the different sources of the edible oil and the main fats, and also about the processing and refining of the oil and fats. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platform like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. For a further query, you can also ask your query to the helpline number that are already mentioned in your slide, that is 708083. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.